Hello again, physicists. Today's topic relates to inertia and force. So to begin, what is inertia? Well, in class, we kind of determined that inertia is the tendency for an object to resist a change in its state of motion. And specifically, when we're talking about the state of motion changing, it means that either it's moving from rest into some sort of non-zero velocity, or the velocity of the object is changing, which essentially means that we have a change in velocity, or in other words, we are accelerating. So if we have a change in state of motion, it means the object must be accelerating. Now, not all objects will react the same way to a change in its motion, and that resistance is what we call the inertial mass of the object, which is again measuring the object's inertia, its ability to resist a change to its state in motion. So keep in mind that if you have more inertial mass, it means that the object has more resistance to a change in its state of motion, or a change to its velocity, less likely to accelerate. So what I have here are two different masses, one that is 100 kilograms, the other is 10 kilograms. They have different inertial masses. The way we would interpret this is if we were to somehow try to influence its state of motion, since the 100 kilogram mass has 10 times the amount of inertial mass, it is 10 times more likely to resist a change in its state of motion. It's 10 times less likely to accelerate than the 10 kilogram mass is. So that's kind of how you can compare, based on inertial mass, how an object will react to a change in its state of motion. We also in class determined that we had a specific name for this thing that was capable of changing the state of motion for an object. And we call that a force. And it's important to understand that a force is not something that will change a state of motion for an object, but it has the ability to. And with a force, it will always have to require two objects that are interacting. It takes two to accelerate. So some examples of where there are forces involved. A dog pulling on a leash. Well, our two objects there would be the dog and the leash. Hammer hits a nail. There's a force there. Okay, what are the two objects? The hammer and the nail. With a falling apple, it accelerates because there is a force involved. The two objects that are involved in this force are the apple and the earth. And a rocket blasting off, where again we are accelerating. Here the two objects that are interacting are actually the rocket and then the gas inside of its fuel tank combusting. So again, just keep in mind, if you are going to have a force, there must be two objects involved. An object cannot exert a force upon itself. It needs a second object to exert that force for it. All right, last thing is, when we talk about forces, really they're going to fall into one of two categories. Either that force will be considered a contact force, where it's resulting from direct contact between the two objects involved. Examples of a contact force include applied forces, normal forces, and friction. Whereas the second category is a field force, where this force is acting from a distance. This would include gravity. If you think about it, when an object is falling, it is accelerating, it's experiencing a force between itself and the earth. But that object isn't in direct contact with the earth. So that's what we mean by acting at a distance. Other examples of field forces include electromagnetic forces, as well as the weak and strong nuclear forces, which we will discuss in a little more detail at the end of our unit. That's all I have in terms of new stuff for you today, physicists. So until next time.